Hey Jeff, can you turn those front lights off for the machines? So I want to talk just a little bit about improving. Adam asked me to talk about improving hay quality. And we're going to talk a little bit. If you guys have questions, just stop and ask. I'm recording this presentation to put on our YouTube channel. Our YouTube channel has about 300 videos on it on all facets of forage and livestock production. You can reach our YouTube channel at KY Forages YouTube. If you just search that, it's going to come right up. There's a number of videos on hay and baleage and grazing management, about anything you can think of. KY Forages YouTube. Yeah, just write YouTube, KY Forages YouTube. It'll be the first, second, or third thing that pops up. Yeah. And you know, last year we had 172,000 views on that channel. Wow. Good. And my wife's like, who in the world is watching that? And but everywhere I go, people say, well, I was watching the YouTube channel. So, all right. I want to talk a little bit about improving hay quality tonight. And I always like to start out with the first question of what's hay quality mean. We talked about different things. There's lots of different things on these tests. There's crude protein, there's acid detergent fiber, neutral detergent fiber, total digestible nutrients. We've got crude protein. All those things are part of forage quality, but what's forage quality really mean? Anybody have any ideas how you would define forage quality? At the end of the day, what forage quality really means is the ability of that forage to produce a desired animal response, right? So if I'm feeding it to a dairy cow, what's my desired animal response? Milk production, right? And the better the forage quality, the more milk she's going to produce. Now, forage quality is kind of a moving target. You know, if you have a brood cow, her requirements are going to be lower than a dairy cow. And if you have a horse, their requirements are going to be, depending on the type of horse, you know, similar to a dairy animal, a little bit higher than a brood cow. So depending on what you're feeding is going to impact what forage quality means to you. And this is kind of what this chart is showing. And I'm not going to go over all the numbers, but the point that I want to make is that it's kind of a moving target. So an animal that's young and growing like a beef steer is going to have a higher requirement for both crude protein and energy, and that's total digestible nutrients and crude protein, than a dry brood cow. So the point that I want to make with this is that we need to define what level of forage quality that you need. If you're a cow-calf guy, you don't need dairy quality hay. You need hay that's going to meet the requirements of a brood cow, but not a lactating dairy cow. If you're a horse person, you'll need decent forage quality, but maybe it doesn't have to be all that high because you're probably feeding a little supplement along with that hay. What's really important in a horse hay market? So it's kind of interesting, but guys that sell a lot of horse hay, they don't usually test for forage quality, right? Because that's not that important for them. What's important? It's weed-free, right? It's what? Cheap? Well, I don't know about cheap, but teeth. It's palatable, right? You want your horse to eat it. And what color does it have to be a good horse hay bale? Green, that's right. If it's off just a little bit, then you're going to get a discount in the horse hay market. So even if it's more mature, but it's still green, then people that are buying horse hay are usually happy. Let me see here. All right, so the only way that we really know what's in a forage sample is to get, or what's in a hay is to get a forage sample. And how we sample is really important. We've got to get a representative sample. One of the publications that you got tonight was on hay testing, and it tells how to get that representative sample. So you want one hay sample to represent one hay lot. So what's a hay lot? A lot is one harvest from one field. So if I had 3 fields, first harvest, I would have 3 hay lots. If I had the second harvest and I only harvested 2 hay fields, I'd have 2 hay lots. And each one of those hay lots should be sampled separately. So this is the publication that you received tonight. It's a nice, simple to read publication. And even if you don't want to read the whole publication, in that inset box is all the main points from that publication on how to get a good hay sample. Now, one of the important things to remember when you take a hay sample is you want to submit the whole sample. So you don't want to try to separate it. And the reason why, it's hard to see on this picture, but when you core a hay bale and you put those cores in a bag, the fine particles are going to go to the bottom. So, or say you put them in a bucket and then you're going to take part of that sample. So you reach your hand in that bucket and grab it. What are you grabbing? The biggest pieces. And the biggest pieces are going to tend to be the lowest in quality. So you want to submit the entire sample to the lab and they'll grind that entire sample and then subdivide it. So there's a number of factors impacting forage quality. The species, legumes tend to be higher than grasses. The life cycle, so annuals. So what would be an annual grass that we will grow around here? Go ahead, don't be shy, throw it out. What's some annual grasses? Sudex would be an annual. That's a warm season annual. How about a cool season annual that we might grow for hay? Wheat, yeah, wheat, cereal rye, barley, oats. Annual ryegrass is a popular one. Those are all annual grasses. What's perennials that we grow? Fescue. Our most important grass is tall fescue. It's a cool season perennial grass. Orchard grass would be another important one in terms of the hay market. Photosynthetic pathway. So we have 2 distinct photosynthetic pathways, right? We've got the C3 pathway in our cool season grasses. That makes them well adapted to growing in the spring and the fall, but not so well during the summer months. And then we've got the C4 pathway that we find in our warm season grasses. Things like Bermuda grass, sorghum Sudan grass, pearl millet, crabgrass. That's our warm season grasses. The C4 photosynthetic pathway is most productive during the summer months. It's able to handle those higher temperatures better than our cool season grasses. And that's why they tend to grow during the summer months. And those, as we move into this part of the state, the warm season grasses become a more important part of our grazing and haying systems. In fact, Junior just planted some Bermuda grass at his place last year. We're doing a little project. We've got 3 different varieties there, and maybe we'll have you out this summer if it didn't die in the 3-degree temperature this winter. So I'm hoping it didn't. But we're pretty excited about that because Bermuda grass can be a pretty productive hay crop if it's managed well during the summer months. Temperature. So as temperature increases, the fiber in forage tends to increase. So whether you're a cool season or a warm season grass, the concentration of fiber tends to increase, and that decreases forage quality. So as fiber increases, forage quality goes down because it becomes less digestible. Fertilization. What's fertilizer prices been like the last couple of years? Really high, right? And sometimes we may have skimped a little bit on our fertilizer, but it's an important part of producing a good quality hay. Impacts both the yield and the crude protein. Time of day when we harvest, is that important? It can be. The carbohydrates and the sugars in the plant tend to be highest when? Late afternoon, that's right. So it's gone through a whole day of photosynthesis, and that's when it's going to have the highest concentrations. Does that mean we should wait until late afternoon to cut our hay? Probably not. In our humid region, we need to be cutting hay when we have that window. And usually we want to optimize or maximize the amount of drying time, so we would cut as soon as the dew got off in the morning in most cases. In the western United States, where they don't have to worry about rainfall because they're in irrigated systems, then they could cut in the afternoon to capture that value of those increased carbohydrates. Stage of maturity at harvest. Vegetative is going to be better than reproductive. So if it's got a seed head on it, then the forage quality has started to decline for sure. If it's nice and leafy and there's not a lot of stems and seed heads, then forage quality is going to be higher in that hay. Harvesting conditions, of course, if it gets rained on, we're going to lose quality. And it depends on how much rain, but it can be a significant amount of quality. And then storage conditions. So after we do everything right and we store that hay outside for 6 months, you know, we can lose some forage quality in that storage. So we can't talk about all that tonight. So what I really wanted to focus in on was a couple things. I want to talk a little bit about fertilization, and because I think it's important and it's something you need to be thinking about. Fertilizer prices are starting to creep back down, so that's a good thing. And then stage of maturity at harvest. So real quick, soil fertility directly impacts stand productivity and persistence. So that means how much it yields and how persistent it is. In one of the first farms that I went to when I came to Kentucky 5 years ago was on the other side of the lakes here, and it was a Bermuda grass operation, and he said, I don't know what's happening, but my yields have just gotten lower and lower and lower. And sure enough, when we sampled the soil, he hadn't been putting enough potash on that field. And that's a very common problem with hay production because we remove a lot of potash. And so once he got that potash back in line with the other nutrients, productivity came back up in that field. So soil fertility directly impacts forage quality and directly impacts forage quality, but to a lesser extent than yield. And it's most closely related to crude protein and warm season grasses. So things like Bermuda grass respond very well in terms of increasing crude protein to nitrogen fertilization. These are some graphs. I'm not going to talk about them, but that shows a relationship between fiber and crude protein. Probably the most important thing to remember about soil fertility is that if we really want to increase forage quality, we need to add legumes to our stands. So when we add legumes, we're going to increase forage quality. We're also going to decrease the amount of nitrogen we need because those legumes will be fixing nitrogen that will be shared with the grass plants in those stands. So by having good soil fertility, we're indirectly impacting quality by encouraging more legumes in our hay stands. So just to mention that not unlike hay sampling, soil sampling also is based on getting a good representative sample. We should sample each field separately, and samples shouldn't represent more than 20 acres. We're going to quantify soil pH, or another word for that would be soil acidity, and phosphorus and potassium, but not nitrogen. Nitrogen is very difficult to measure because it's a very transient nutrient in the soil. But we'll give a good value for both phosphorus and potassium. And it provides you baseline data. And probably the most important time it's always important to soil test, but the most important time is when fertilizer prices are high, because it really allows you to target your application. So if I have adequate phosphorus, I don't want to be putting any more phosphorus on now because it's expensive. Same way with potash. And it also allows us to know whether we need lime. If we have a low soil pH, this is a great time to put lime on because lime impacts the availability of all the other nutrients in the soil. As we get into the correct pH range, all of the macronutrients like phosphorus and potassium and calcium and magnesium and sulfur all become more plant available in the soil. So it's easier for the plant to extract those nutrients from the soil. So this is a publication you guys got tonight. It's just a real simple publication on soil sampling, hayfields, and pastures. It's a one-pager. It's worth reading if you're going to soil sample, and I'm sure Adam has got soil probes here that he would loan you. We recommend that you use a soil probe so that you can get a good sample, and the sampling depth is 4 inches. So I know everybody thinks it's silly when I say that, but when I go to field days, sometimes I'll ask, what depth should we be sampling at? I get answers from 2 inches to 12 inches. Our soil sample calibrations are based on 4 inches at University of Kentucky, so we need to make sure that we sample at the proper depth. I wanted to just show you this to show you how much nutrients are removed in hay, because it's quite a bit. If we look, for example, at orchard grass, every ton of orchard grass has about 36 pounds of nitrogen in it, about 15 pounds of phosphate, and about 55 pounds of potash, that's K2O. If we have a good year with orchard grass and we yield 3 tons, all of a sudden we're removing from that field 100 pounds of nitrogen, 45 pounds of phosphorus, and around 170 or 160 or 170 pounds of potash. We have to put that back. If we don't put that back on the field, then our productivity is going to come down. Not immediately, but over time we're going to mine the nutrients out of that soil. So it's really important that we put back what we take out of that field. And the one nutrient that we always fall short on is potash. We hardly ever put enough potash on, so it's really important to watch that in your soil test levels. So, well, it depends on the nutrient. So I guess the question is would you split your applications? The answer is ideally you would split your applications, and some of our best alfalfa producers in the state will put an application of fertilizer on after each cutting. Most people will not do that. But the more you spoon feed those nutrients to that hay crop, the more efficient it's going to use those nutrients. Generally speaking, for a high producing alfalfa crop, we would want to put on, split it into at least 2 applications, one after the first cutting and then one after the third cutting, so that it's got good nutrient status going into winter. So the single most important factor impacting forage quality is stage of maturity at harvest. If you go home tonight and remember one thing from what I said, stage of maturity at harvest, that's the single most important factor impacting forage quality. If you can cut it at the right stage of maturity, that's going to go further to increase the quality of your hay than anything. So this is just a real simple diagram going from a leafy vegetative state to a reproductive state where it's at full bloom. And what we see is that as that plant matures and we go towards full bloom, our yield increases. But our digestibility in the amount of that forage the animal can eat, the dry matter intake, decreases. And so the question is where do we want to be on this scale? If we're all the way over here, we've got a really great forage quality, but not a whole lot of hay, right? If we're all the way over here, unfortunately, in Kentucky, we tend to be over here. We like to maximize the quantity of hay that we're producing, but the forage quality is very low. So really where we need to be is kind of where these lines cross at. And that's going to be for grasses at late boot or early head when that seed head first comes out. That's going to give you a good compromise between how much yield you get and what the forage quality is. For our legumes, like alfalfa, you want to be at 1/10 bloom, so about 10% bloom. For red clover, we'd say a little bit further past 10% bloom. That's going to give you a good compromise between how much yield you get and what the forage quality is. So one of the questions in this hay set here is an anomaly. Most of the hay that we make in Kentucky is usually lower in quality than this. I've seen instances where the forage quality was so low that animals were eating as much as they could and still losing weight. That's not uncommon. So the question that I pose is, why don't we do a better job at harvesting at the correct stage of maturity? And there's really lots of reasons. One is that that's not their full-time job. They do something else. They work off the farm. Kids are playing baseball, so things get pushed back. Cattle and forage are a secondary enterprise on farms. So most of the farms, forage will come after row crops or after tobacco, and they kind of get treated like that too, or after a construction business, right? That's making the real money. Older, poorly maintained equipment. I grew up on a farm in Northeast Ohio that I didn't even know when I graduated from high school that they made new equipment, and that was frustrating because things broke, when you tried to use them, and sometimes that delays timely harvest. But now that I'm older, I realize why my dad didn't buy new equipment. It's expensive, right? So poor curing conditions. A lot of times, especially during the first cutting, we'll have conditions that just aren't good for curing hay. And that can be a real challenge for us here in Kentucky. This was some interesting data that Matthew Dixon from the Ag Weather Center, UK, put together. So he looked at the top 10 wettest years on record, and they have records from 1895 to 2020. What was interesting is that 5 of those top 10 years were in the last 10 years. So our climate seems to be getting a little bit wetter during the summer months. We still get droughts, but in general a little bit wetter, and this is kind of what this map is showing. So this 0 would be average rainfall, and then the blue would be increase, and the brown would be a decrease. And this is exactly what we see in the Weather Channel. We tend to have more precipitation in the eastern United States. The western United States is tending to be drier. So this is going to be a challenge for us as hay producers as we move forward. And the question is, how do we manage this? So this was a very interesting thing that Matthew put together. This is baling days. So what a baling day is 3 curing days, so 3 good curing days. The 4th day is a baling day. That's how he figures this with his weather data. And this is what he found. So if we look at, so this is Lexington, Bowling Green, and then Paducah, which would be the closest to us. If we look at the amount of baling days, this was from 2000 to 2021, we had about 6 baling days. From 2017 to 2021, we had 4 baling days. That's a loss of 2 baling days. That's significant. I mean, when you have 6 to start with and you're losing 2, it's going to be a challenge to get that hay put up without getting it rained on. So how do we manage for high quality hay with even fewer baling days? And really the answer is that we need to shorten the period between when we cut it and when we bale it. And there's a couple strategies for doing that. We have to speed up curing or bale to higher moisture. So we need to either cut that period that it takes to dry it out from when we mow it to when we bale it, or we have to bale it at a higher moisture and use something like Baleage as a potential alternative. And that may be one of our best options for really putting up high quality feed in this part of the state, is to bale and wrap those bales. This was kind of an interesting baler. This was Henry Burrell outside of Princeton. He bought one of these balers. It's a McHale baler. It bales and then it wraps the bale all in once and dumps it out the back. And then you pick these, wrap the bales up, and you can stack and store them outside. And there's essentially no storage loss because they're wrapped in plastic. The what? More work? Hay's work for sure. And you've got to take the plastic off. I say the biggest problem with this system is the plastic. What do you do with the plastic? It probably has to be landfilled. We don't have a good outlet right now for recycling. All right. I wanted to put this diagram up, and I'm not going to spend a lot of time on this, but I want to show you how hay dries down. So when we cut a hay crop that's standing in the field, it's about 80% moisture. It dries down very rapidly, and then until we get down to around 30% or so. At 30%, the drying rate slows down considerably. So it takes a lot of time to get from that 30 to 20 where we really need to be to bale dry hay. Now, what moisture would we ensile hay at or make baleage? Probably somewhere around 50 to 60%. So we can wilt that hay relatively rapidly and wrap it. So in most cases, if we have decent curing conditions, we can cut hay one day and wrap it the next day. Not with dry hay. With dry hay, we need probably 3 days, maybe sometimes 4 days, depending on the curing conditions. So one thing I want to show you is that, does anybody know what the stomata is in a leaf? Stomata in a leaf are like little holes in the plant leaf. And they let carbon dioxide in to get fixed during photosynthesis. They let oxygen out, and they also let water vapor out. And the way a plant cools itself is it takes water from the soil up through the plant stem and then out through the leaves through those holes. And it's kind of like a transpiration, they call it. It cools itself that way. The stomata are pretty neat. So this is a photograph of a leaf blade with a microscope. And each one of these little circles are stomata, or the holes in the leaf. It's not really just a hole, though. It's two specialized cells called guard cells. And those guard cells can change their shape. So the hole can go like this, closed, or open up like this. So when a plant goes under drought stress and it needs to conserve moisture, it'll close up. So when we cut hay, the stomata is open. And when the stomata is open, it lets that moisture out through the stomata. And that's kind of what this diagram was showing. It lets moisture out until the plant gets down to about 60%. And then the stomata close. And then there's no more loss through the stomata. When we condition a plant, and we'll talk more about this, we help to cure it by either breaking the stem to let moisture out, crushing the stem to let moisture out, or abrading the stem depending on the type of conditioner that we have. And when we abrade the stem, it removes a waxy layer on the stem and allows moisture to escape through there. And that is effective down to around 30%. And then the drying really slows down as we get down to around 20%. So a couple tips for increasing the drying rate in dry hay. And the first one is to mow at the proper height. So why is that important for drying, to mow at the proper height? Anybody know? It's more of a physical thing than anything. It's, why my clicker's not working real well tonight. So if we mow grasses at 3 to 4 inches, we're going to leave some stubble in there. And that's important for grasses for several reasons. Number one reason is that the grass stores energy for regrowth in the stem base. So if we leave 3 to 4 inches of residue, we're leaving that stored carbohydrate. The other thing that does is that it makes a physical structure that actually holds the forage away from the soil surface, and that aids in drying that forage. And the same thing holds true for alfalfa, 2 to 4 inches. And again, it helps elevate the crop, and it breaks contact with the ground so that we can dry that forage faster. So cutting at the right height is good for the plant and is also good for curing as dry hay. If we have the forage sitting right on a wet soil, it's going to be wicking moisture up from that wet soil and it's going to slow the curing process down. The second tip is to condition your hay crop. How many of you have a conditioning system on your mower? Anybody? Good. Yeah, not many people, because it increases the price of the mower if we put a conditioning system on. But conditioning systems are pretty important. It's kind of funny, you know, I guess it's 40 years ago, you know, when I was growing up in Northeast Ohio, we had a sickle bar mower. I don't even know if anybody remembers what a sickle bar mower is, but we would cut hay with that. And my dad actually, it was kind of ahead of his time. He had a John Deere crimper. I don't know if you've ever seen that. It was like two corrugated pieces that went around rollers like this that meshed. And after we would mow that crop with the sickle bar mower, we would come back and crimp it to increase drying rate. So that was kind of neat. The thing about mechanical conditioning is that it can almost double your drying rate. And that's pretty amazing. When we're talking about short periods for getting that crop up due to rainfall events, you know, being able to double that drying rate is really important. The reason I'm telling you this is if you're in a cash hay business, you've got to get a conditioning system on your mower, because it's going to really help with the curing time. There's two types of conditioning systems. We have a roller type conditioning system. That's better for alfalfa and legumes because it's gentler on the plant. It's going to go through two rollers that intermesh usually, and that's going to crack that stem and crush that stem, and it's going to let moisture out. It's gentler than a flail type or an impeller type conditioning system. The flail type or impeller types are better suited for grass than for legumes. And again, it doesn't crimp the stems like a roller type. It abrades the stem. The impellers actually pull some of that waxy coating off of the stem to let the moisture out. It's an effective system. It's just a little bit more aggressive on a plant like alfalfa that has the fine leaves. And the same would hold true for Sericea lespedeza probably. And that can be difficult to make as good dry hay because the leaves tend to dry faster than the stem. So you have to be really careful that you get it dry enough, but not too dry to cause a lot of leaf shatter at harvest. Okay, the key thing to remember about any conditioning system is that it's only as good as its adjustment. So you've got to make sure that they're adjusted properly. And there's notes and bulletins and videos on how to properly adjust those systems. And the specification should be in the owner's manual of your particular mower conditioner. This is another big one, the conditioning, and then this one is a really important tip, and this is to maximize swath width. It drives me batty when I go down the road and I see somebody with a mower conditioner and they've got the wings all the way in and they're putting all that forage in a swath as wide as this table. If we want to maximize or optimize drying time, we want that spread out as much as we can. We want to be at least 60% of the mower width. So that means if we got a 10-foot mower width, we want that swath to be at least 6 foot wide. The wider it is, the better. That makes a less dense mat on the soil surface, and it exposes a greater surface area to the sunlight, and that's going to cure that considerably faster. The other thing it does is that it tends to keep the crop further off the ground. So if you just think about this for a minute, if I've got forage and it's 80% moisture, it's got a lot of water in it. If I concentrate it in something as wide as this table, there's going to be more weight pressing down on that windrow. If it's spread out on 3 table widths, then it's going to be a lot less likely to press down to the wet soil. And if you're going to ted it as soon as you cut it. Don't wait for the ground to dry out, because when that forage is concentrated in a smaller windrow before you ted it, it's not drying. Just the surface of it's drying. We want to get it spread out as soon as we can to optimize our drying time. And this is the impact of swath width on drying rate. And so there's the dotted line here is a wide swath, and the purple line that's solid is a narrow swath. So what I want you to notice is they're cut at the same time. They're about 80% moisture. To get down to around 20% moisture, or that's the moisture we would harvest at, 18 to 20 for most hay packages. It took us 32 hours when we had a wide swath. With a narrow swath, it took them 56 hours. If you condition a crop and you make a wide mowing swath, it's going to be like night and day for your curing time. So that's really 2 really important things to remember as you go home tonight. And then rake at the proper moisture, right? And that's going to be a little bit different for the crop. So what raking does, we call it consolidating, but all it does is put the forage into a windrow that we can harvest with whatever we're going to harvest. If we're going to chop it or if we're going to bale it, we want to put it into a windrow so that we can harvest it. The other thing it does is it reorients the forage, or it turns the bottom up. So that's going to turn the wet forage up so that it can be exposed to solar radiation and dry. We want to rake alfalfa and clovers at 40% moisture. And that's going to help reduce leaf loss. Grasses, you know, we can go down to around 25% moisture and still be okay. And the reason why is that we don't have those fine trifoliate leaves on grass plants. We're going to have much less leaf loss than we would with a legume plant. So if it gets too dry, don't rake it. Wait until you get some dew on it before you rake it, and it makes the leaves more pliable. And then make sure you set your tine so that you have minimal soil contact. Probably the worst rake for soil contact would, of course, be the V rake, right? Because it's dragging those along the soil surface. It's a popular rake because it's pretty wide, but it can get a lot of soil in that forage. And when we get a lot of ash, when we burn it, the forage off, what's left is the soil. When we have high ash content, that's negatively related to animal performance. So we want to minimize the amount of soil we get into the forage. And there's a couple different rake styles. So we've got a V rake here, an old roller bar rake, which is still a pretty good rake if it's set properly, and then a side delivery rake is probably the first choice for rakes in terms of being gentle on the crop. Tip 5, use hay preservatives. Not always, just in specific instances, but they can allow you to harvest at a slightly higher moisture. The goal is to, of course, speed up harvest, and it allows you to harvest at a little bit higher moisture. We have 2 categories of hay preservatives, but really only one is used. We have drying agents, and the drying agents, what they do is chemically strip that cuticle off of the stem of the plant and allow moisture to escape. They would be something like potassium carbonate that would be sprayed on as you're mowing that crop. Not very popular, or more popular class would be mold inhibitors, and that would be something like propionic acid. Both are applied as a spray. Coverage is essential, so getting uniform coverage is really important. You can buy kits to put on balers to spray it as the forage enters the bale chamber or the pickup as it's going into the bale chamber. They can range anywhere from $1,000 to $7,000 depending on how technical you want to get. If you want something that's going to read the moisture, like this middle picture here, has a star wheel that kind of gives you an idea of the moisture of that crop, and then increase or decrease the rate automatically, it's going to be more expensive than something that you do manually. So when we talk about microbial inhibitors, the most popular one would be buffered propionic acid. And we know this works. This is the one that we know 100% works. And a lot of the buffered propionic acid will have just a little bit of acetic acid in it. They say it helps to maintain the color of the forage. Now this is by no means a miracle cure for moisture. It's going to help you preserve hay up to 30%, but even 30% moisture is pushing it. So really its most effective range will be when it's just a little bit too wet to put in that hay bale, so in that 20 to 25% or 26% range. And of course, as moisture goes up, the amount of propionic acid that we need to put on a ton of hay is going to increase from about 4 to 16 pounds per ton. Now, when do we use this? We use this when the hay's almost dry enough to bale, but not quite, and it's going to rain, and rain's imminent. If it's not going to rain, then just leave it sit out in the field for a little bit longer. Whenever we add another piece to the puzzle, you know there's an increased cost associated with putting a hay preservative on. So I just want to kind of finish this section up and talk about best management practices for hay. Mow at the correct stage of maturity, which would be what? The boot stage. Very good, June. Somebody's paying attention tonight. So boot stage or early bloom for legumes. Mow early in the day. So don't wait till the afternoon to mow to get those extra sugars and carbohydrates. We want to optimize or maximize our drying time. That means mowing in the morning as soon as dew gets off the plant. Use a mower conditioner to reduce drying time. Make a wide swath. Those two things right there will really speed up drying time in the field. Rake at the proper moisture, so 40% for legumes, 25% for grasses. Bale at 18 to 20% moisture. So we want to bale at a low enough moisture that will inhibit mold growth, and we found that to be around 18%, but not at a super dry moisture where we're going to start to lose leaf blades on alfalfa especially. If it gets too dry, then we need to delay baling until we get some dew on that crop to soften those leaves and make them more pliable. Otherwise, we'll have very high leaf loss. Let's see here. And then ideally, if you can store your hay under cover, that's the best scenario. We can get significant moisture loss by storing the hay on the ground. We always think of moisture loss coming from rain, right? Falling down in the bale, but a lot of the moisture is wicked up from the soil surface and wicked up into the bale, and that causes a lot of loss in that particular bale. So I just want to finish up and talk about baleage as a rain management tool. And I didn't talk a lot about baleage tonight, and we don't really have enough time, but people are starting to use it kind of as a rain management tool. And the way they're using it is they're ensiling hay that's not quite wet enough for silage, but not quite dry enough for hay. We've always said there's this no man's land between 20 and 40% moisture where neither hay or silage will do a good job at preserving the forage. But there's more and more people that are starting to make what they call sweet hay in this range and having fairly good success. And they refer to it as sweet hay. It doesn't really go through a full fermentation. It's a partial fermentation. I'll show you some data in a minute. And they're using this kind of as a rain management tool. I think the first time I encountered this was maybe 10 years ago. There was a producer, cash hay producer in Northeast Ohio, and the way he would use this is he would aimed to make dry hay, but if it wasn't quite dry enough and it was going to rain, he would bale it up and then wrap it with about 8 layers of plastic. And he referred to that as sweet hay, and it was a fairly good hay product. So we did a study at the research station, one of my interns a few years ago, and evaluated the moisture content at Ensiling on the pH. So that's pH is an indication of fermentation. Ideally, we'd like to have a pH below 4, although we hardly ever get it with grass hay. The lower the pH, the better for Ensiling. That means it went through a better fermentation, and it's going to be a more stable product. And then we evaluated nutritive value: crude protein, total digestible nutrients, acid detergent fiber, neutral detergent fiber. So what we did was we took fescue at the research station. It was a little bit too far along, but we were just following our field crew, and it got delayed a little bit. And we started to ensile it. We started at 80% moisture, so that's about standing moisture in the field, and then followed it every 2 hours or so with a sample, and ensiled that little sample in a small bag. I'll show you in a minute. And we looked at the pH and the nutritive value. So this was the impact of dry matter at ensiling on pH. So when this was standing forage in the field, around 25% moisture, that's when we had our greatest pH reduction. That's our best fermentation. We were about 4.6 or so on this particular fermentation. Now, as the dry matter increased, so as that plant started to dry out and we came up here close to 80 to 90% dry matter, we hardly got a pH reduction. So that is around 6. So this was not going through a fermentation, even though we put it in an airtight bag and closed that bag up and sucked all the air out. We weren't getting that fermentation. What I want you to realize is that as that forage crop dries out, the fermentation decreases. So the optimal moisture for ensiling baleage at would be around 50 to 60% moisture. When we get below that, we start to restrict fermentation. Now, even though we restricted fermentation, that's what I was going to tell you, we did not have any mold in these samples. So as long as we excluded air from these samples, we did not have any mold.
What did you do with the
mice and the voles? Well, this was in lab in a box, but they can be a problem for baled, and birds can too for wrapped and other critters that can tear it. If you're going to make baleage, you've got to be really cognizant of holes in that plastic film from varmints, and make sure and patch those with a good quality tape designed for silage film. What I wanted to show you with this is that this is the total digestible nutrients, or the energy in this, and it was unimpacted by moisture at ensiling. So even though it was dry, we did have very little effect on the total digestible nutrients. Now the key was oxygen exclusion. You got to have good oxygen exclusion. So that means if you're going to wrap hay that's below the ideal moisture range for baleage, you've got to put 6 or 8 layers of plastic on that bale to make sure we keep oxygen out. If we get a hole in that plastic, that's when we can start to see those bales mold and start to break down.
What does it cost if you wrap it 6 times, what does it cost per bale?
$4 to $5 a bale. All right, I'm going to finish up here and just give you the take-home points. Sustainable hay production is going to be dependent upon a well-designed soil fertility program. So make sure you monitor your soil fertility. And in the hay production system, I'd like to see you take a sample every year. In pastures, we can get away with sampling every 2 or 3 years. But hay production, because we're removing so many nutrients, it's good to get a sample every year. Single most important factor impacting forage quality: stage of maturity at harvest. So if you can cut it at the right stage, that's going to really increase your forage quality. If you're not using the conditioning system, it could really benefit you in terms of shortened curing time if you're trying to make dry hay. The research shows they can cut curing time in half if you're making dry hay, which is pretty important when you have a limited number of baling days. Wide swath can significantly cut drying time. So the wider you can make that swath coming out of the back of the mower conditioner, the better off you are because you're getting more solar radiation on a greater surface area. And that's going to decrease your drying time. And bale silage can be a good option for shortening that period between cutting and baling. In the ideal situation, you can cut one day and bale the next day with bale silage if you have decent curing conditions. And that really enables you to cut at the right stage of maturity. And that's really important. So by having that short time, I don't have to wait to 4 days, have a 4-day period without rain. If I have a 2-day period without rain, I can cut it, get it wrapped up, and be done. And with that, I'm finished. Is there any questions? And it doesn't have to be on hay, it can be on anything. Forage related, ideally. And, I think there's probably some truth to that. Where you get caught is when it rains for a week and a half or 10 days at a time. And then it's one thing to get a little sprinkle on a hay crop, but when you get caught and it doesn't clear up for a week or two, then you're in real trouble. So, is there any other questions? Yeah. So it can use either a net wrap or plastic, and so the way that baler works is that it wraps first around the outside of the bale like this, right? So not the ends. It wraps, and then you can use plastic for that. And when I wrap like this first, and then I wrap the ends like this, it cuts down the amount of total plastic that you use. Because when you wrap the bale, when a bale just sits on a platform and rotates 2 ways at once, it always puts about twice as many layers of plastic on the ends of the bale versus the sides. So by wrapping it first, like instead of using net wrap, it uses that plastic. And then wrapping the ends second, it decreases the total amount of plastic. It's a neat baler. It's not inexpensive. So, yeah. It's close to 100,000 probably. Yeah. Yeah. But you buy a regular barrel, what's a regular baler cost? 40,000? Yeah, 40 to 60,000. So, yeah. Is there any questions? Well, thanks for your attention, and I'll be around if you have any other questions.